Welcome to Daily Papers, the podcast where we break down the latest and greatest research papers into something you can actually understand.
Today we're talking about artificial intelligence, specifically how we can get AI to not just spit out facts, but to actually reason through complex problems. Think of the difference between a student who memorizes multiplication tables and one who can solve a tricky word problem they've never seen before.
Right, and we've all seen AI do amazing things, but we've also probably asked it a question that seems simple only to get a completely nonsensical answer. Getting AI to think logically is one of the biggest challenges in the field.
Exactly, and that brings us to today's paper, Eliciting Reasoning in Language Models with Cognitive Tools by researchers at IBM and ETH Zurich. They have a fascinating new approach to this problem that's inspired by, of all things, how our own human brains work.
I'm intrigued. So before we get into their solution, what's the problem they're trying to solve? We know large language models, or LLMs, like ChatGPT, are incredibly powerful. How are people currently trying to teach them to reason?
Well, a popular method is called chain of thought prompting. You basically tell the AI, hey, don't just give me the answer, show me your work. And that helps a lot. Another way is through something called reinforcement learning, where you essentially give the AI a treat when it reasons correctly.
So you're either telling it to be a better student or training it like a pet.
A very, very complex digital pet, but yes. And those methods work. But this paper asks a really interesting question. What if the ability to reason is already inside the AI? What if it learned these skills from the vast amount of text it was trained on, but it just doesn't know how to access or organize them?
So the reasoning is latent, just waiting to be woken up. How do you do that?
This is the cool part. The researchers looked at cognitive psychology. When you or I face a tough problem, say a complicated math question or assembling a piece of furniture, we don't just stare at it and hope the answer appears. We use a set of mental steps.
I know what I do. First, I complain. Then I try to figure out what the question is actually asking. I might think about similar problems I've solved before. Then I'll try a step, see if it works, and if I mess up, I go back and try again.
You've just perfectly described the solution in this paper. They created a set of cognitive tools for the AI, which are direct analogs of those human reasoning steps.
So they gave the AI a mental toolkit. What's in it?
There are 4 main tools. First, there's the Understand Question tool. This tool makes the AI stop and rephrase the problem, identify the key parts, and figure out what it needs to solve.
Okay, that's step 1 for any good problem solver. What's next?
The Recall Related tool. This is like the AI saying, this problem about trains leaving stations reminds me of 3 other train problems I've seen before. Let me look at how those were solved. It pulls up relevant examples from its own knowledge.
That makes sense. Learning from past experience.
Then there's the Examine Answer tool. This is the double-check your work step. It looks at the reasoning so far and asks, are there any logical flaws here? Did I make a calculation error? Did I miss something? It's a form of self-reflection.
A skill many humans could use more of. And what's the last tool?
The Backtracking tool. This is for when the AI realizes it's gone down a dead end. Instead of giving up or starting over, it can say, okay, step 3 was a mistake. Let's go back to step 2, which was correct, and try a different approach from there.
So how does this all work in practice? Do you just give an AI a math problem and hand it this virtual toolkit?
Pretty much. The AI acts like a project manager. It starts trying to solve the problem, and whenever it feels stuck or thinks a specific step would be helpful, it calls one of its tools. The tool then runs as a separate focused task and feeds the result back to the main process.
It's like the AI is delegating. Instead of one big brain trying to do everything, it has these little specialist consultants it can call on. A consultant for understanding, a consultant for checking work.
That's a perfect way to put it. This makes the whole process modular. Each piece is separate and focused, which prevents the AI from getting confused by trying to do too many things at once.
This all sounds great in theory, but this is daily papers, so we need to know, did it actually work? What were the results?
The results were pretty spectacular. They tested this on several very difficult math benchmarks. We're talking problems from high-level math competitions. For one model, GPT-4.1, its baseline accuracy on a test called AIM 2024 was about 27%.
Which is okay, but not amazing for a competition.
Exactly. But when they gave it the cognitive toolkit, its accuracy jumped to over 43%. And that was without any expensive, complicated retraining of the model. All they did was give it a better way to think.
That's a massive improvement. It nearly doubled its performance just by having access to these simple-sounding tools.
It really is. And the improvements were consistent across different AI models and different math tests. It strongly suggests that these models do have these powerful reasoning abilities baked in, and this method simply unlocks them. It's less about teaching the AI new knowledge and more about teaching it good problem-solving habits.
So what's the big takeaway here? Is it just about making AI better at math homework?
That's a great application, but the implications are much bigger. This is about making AI more transparent and reliable. When an AI just gives you an answer, it's a black box. You don't know how it got there.
But with this method, you can see its work. You can see it called the understand question tool, then the recall related tool, then it backtracked. You can follow its logic.
Precisely. And if it gets the answer wrong, you can see where it went wrong. Did it misinterpret the question? Did it recall an irrelevant example? This is crucial if we ever want to trust AI with high-stakes decisions in fields like medicine, law, or engineering.
So it's a step towards an AI that can not only solve problems, but can also explain its thinking in a way that we can understand and verify.
Exactly that. It's about building AI that doesn't just act smart, but thinks in a structured, scrutable way. And that might be just as important as getting the right answer.
A fascinating paper that gives AI a toolkit for thinking. That's all the time we have for today. Thanks for tuning in to Daily Papers.